Good afternoon, everyone. My name is George. I'm a principal software engineer at Collabora. And today I'm going to talk to you about the status of PipeWire, the current status of PipeWire. PipeWire is a multimedia inter-process communication framework. That's I think the most accurate way to describe it. It's a framework that allows different processes on your Linux system to be able to share audio streams or video streams or MIDI streams between each other. And it also allows those processes to access devices like audio cards and DSPs through the ALSA API, Bluetooth devices through Bluesy, camera devices through V4L and libcamera. It allows accessing network devices as well, as it supports network protocols like AES-67, AirPlay, NetJack, and some more. And it also has functionality to do lightweight processing on the fly, so things like resampling audio, asynchronous rate conversion, format conversion, some audio filters, so you can implement digital signal processing directly in software in PipeWire. Things like that. It's a very, very powerful, low-level multimedia framework that you can use to bridge the gap, basically, between your devices and your applications and interconnect them. Now, PipeWire is deeply connected to the automotive-grade Linux project, as AGL was actually the earliest adopter of PipeWire in 2019. And WirePlumber, which is the companion session manager for PipeWire, was originally written for AGL. It was originally targeting AGL only, and desktop support was added later in version 0.3. I think it wouldn't have made an impact without AGL, and nowadays, it's actually used in production vehicles and a lot of other kinds of devices, like handheld gaming devices, professional audio devices, musical instruments, healthcare devices, and many, many, many more. So thank you, AGL. So I will go through now what has changed in the past year on the PipeWire project, what has been going on. That's what I will be talking about. During last year, there were two major releases of PipeWire, version 1.2 in June 2024 and version 1.4 in March 2025. Now let's see what's new in version 1.2, so what was new basically last year. 1 year before today. First of all, asynchronous processing. So we added support for nodes to be able to process with one cycle of latencies so that they don't block processing. Normally, in PipeWire, we have this view of nodes where we have a client application that creates like a playback stream that is represented as a node object in PipeWire, and that is reflected on the PipeWire daemon. And then we may have other nodes that are filters or other processing nodes. And then we have a node which is probably the ALSA sink, where the audio goes to be played out to the speakers. And normally the device node is what we call the driver. It means that it uses device interrupts or a timer to wake up the whole graph and request it to process data. So what happens is, let's say there is a timer here that wakes up every, 21 milliseconds or so. And every time it wakes up, it will trigger all the other nodes, and then there is an algorithm that basically finds out which node needs to be processed first, and then it goes and processes that. So the first node here would be the playback stream there. It needs to produce some audio data in order to be processed by the filters. and then the filters will take the output, they will process it, and then it will go to the async. Now, before we had asynchronous processing, all of that had to complete in one cycle. One cycle means from the time that this timer times out up to the next time that it times out. So if it's every 21 milliseconds, you have just that time to process everything. Now, with asynchronous processing, what we did is there is now 2 buffers on the asynchronous node. So here I have written out this playback stream node as an asynchronous node. And what happens there is it has 2 buffers, a previous and a next one. And every time it produces data, it writes into the next buffer, while the filters take the previous buffer as the input. So now it has more time to actually produce data with one cycle of additional latency. And it doesn't block the graph, because previously we had this situation, this problem that sometimes a node would be too slow, and it would prevent everything from running. Because if a node doesn't complete, if it doesn't produce data on time, then the other nodes don't run, and they are marked as under running, which is not good. And also with asynchronous processing, even if it takes more time than 2 cycles to produce a buffer, it will be marked, the asynchronous node will be marked as under running, and we will fill a buffer of silence to run the rest of the graph. So the rest of the graph doesn't ever block. It's the asynchronous node that might have issues. And we do that now by default for all kinds of playback or capture streams that are coming from applications, so that we are certain that the application is not going to, if the application misbehaves, it won't actually prevent the graph from running. Second feature was support for multi-threading execution in the server. So previously, all of the nodes had to run in the same thread. Every time there was a wake up, every node was scheduled, and every node would be processed one after the other in the same thread. Now we have support for moving certain nodes by configuration to different threads. So here we could have, for example, it's the same graph that I had in a previous example, but now filter 2 runs in a different thread. So if at the time that the playback stream is ready and it has produced data, filter 1 and filter 2 will run in parallel in 2 different threads. And then they can synchronize when writing to the async, or we can also have filter 2 be also asynchronous, so it doesn't have to, so the async doesn't have to wait for the result from there. There's a lot of things that you can do with those 2 features and tweak the graph to fit perfectly your use case. And this also supports CPU pinning, so you can pin certain nodes to run on certain CPU cores, which is kind of useful. Another feature in 1.2 is lazy scheduling, which is very, very useful in video content use cases like screen sharing. So, leaving audio aside, now we're looking at screen sharing. Lazy scheduling is kind of inversing the follower and driver concept. So previously I said usually there is a driver node that wakes up using a timer or some interrupt, and then it schedules the graph. But what if we want the follower, so some other node that is in the graph, to be able to request processing? So 2 examples of where this is useful. One is a headless server, a headless desktop that you are sharing over over the internet, maybe, where the producer node is a lazy follower, is a requesting follower, and the consumer node is a lazy driver. So what happens is that the consumer node, which is basically your streaming application, the thing that streams the video content to the internet, it doesn't try to request a frame every whatever time is. Like if you have 30 FPS, it doesn't try to request 1/30 frames per second. But instead, it waits for the producer to request when it has new data. So if nothing has moved on your screen, there is no need to update. There is no need to send new frames to the internet. So there is no update. And that basically allows us to throttle to the consumer's frame rate. So at the worst case, the consumer will it will request exactly the frame rate that it needs. So it still has control because the driver still has control over when it can get data. But when there is no activity on the actual server side, on the producer, it idles and it doesn't produce anything. And similar, we have the frame encoder example where there is a driver producer. Let's say it's a camera or something, and then you have a consumer, which is a follower, but it's requesting. And the consumer, what it's doing is that it's encoding the video to a stream. By doing lazy scheduling, we can actually request one frame every time there is room for encoding a new one, because usually the encoder runs at a slower pace, and we don't need to send it too many frames when there is an update on the screen or the camera. Other features in 1.2 is the Flatpak security context. So now we have support for creating a server socket, something that looks like a PipeWire server socket, but inside a container, and without passing through the actual server socket. So it's like we have a mirror of the server socket, but if a client connects there, we know that it's coming from the container, and we have the ability to sandbox it on the actual PipeWire daemon. Another thing we added was Vulkan bleed and convert filters that allows doing hardware-accelerated video convert and video scale. Because the idea is to allow for, as we do with audio, when we process audio, we do automatic format conversion and automatic resampling and things like that. So the idea is that we would like to do that for video as well. And the original try to do that was to use Vulkan. So yeah, that was added in 1.2. Also support for explicit sync was added, which goes together with that Vulkan conversion support. And some Bluetooth codecs were added as well. The Google Opus codec, the AAC ELD, and LC3 super wideband codecs for the Bluetooth plugin. Now let's look at 1.4. 1.4 in March 2025, 1.4 added support for MIDI 2.0. So now we use the universal MIDI packet format as the native MIDI format in PipeWire. Every MIDI packet around the graph of PipeWire is exchanged in the universal MIDI packet format. So it's compatible with MIDI 2 devices. And we also have support for I/O through ALSA to use the new universal MIDI packet API to access devices. And of course, there is a converter where needed that converts to the previous MIDI format. So for example, standard jack applications that were previously using MIDI, they don't know how to talk to the new format, and there is conversion on the fly. In 1.4, we also added the FFmpeg-based video converter. So complementary to the Vulkan one, we added also an FFmpeg-based one to do the same thing, but in software, which is needed because not every machine is able to do the hardware-accelerated conversion. And we added a video adapter plugin, which essentially wraps all the video streams, and it can load either an FMPEG or a Vulkan video converter on demand on that node. So if you have, let's say, a camera that produces MJPEG in a certain resolution, and you have an application here that wants to consume raw RGB at a different resolution. If you try to link those together in PipeWire, normally it will fail. But with the converters and the video adapter, what will happen is it will automatically figure out how to convert, what's the best way to convert from one format to the other, and potentially also decode the MJPEG format, which is encoded, to a raw format, and be able to send that to the application. None of that is loaded by default yet, because we're missing a lot of bits. It's still experimental, but it's in the works. Another thing we added in 1.4 is the new filter graph SPA plugin. SPA is the simple plugin API. It's a very low-level API that we use to write plugins in PipeWire. And what we did is we moved the code from module filter chain, which was previously like a full module that you could load. It would create new nodes in the graph that would that would be able to load some DSP filters. Like in the example that I showed at the beginning, there were different nodes that were filters. But now what we can do is we can also load these filters directly into the audio adapter. So any audio node, any audio device, any audio stream that normally has an audio adapter, an audio convert element plugged into it to do the format conversion and the resampling on the fly, now it gets also a filter graph there on the fly, and you can load dynamically filters there to do some processing, some interesting DSP processing. We have some built-in filters there, built-in plug-in filters, like the convolver, equalizer, mixer, delay, specializer, things like that. And we also support loading LADSPA and LV2 plugins, which are the main APIs on Linux for writing professional audio DSP plugins. And yeah, this can all be loaded dynamically. So you can have a device, and let's say you suddenly, this is a microphone, it's producing audio, and suddenly you realize, oh, I want a little bit of reverb on that microphone. You can just load the reverb plugin directly on the device node, and it will start having that reverb immediately. And you can configure it on the fly, so it's very, very flexible. You can do a lot of things with it. Now, other things in 1.4 is Bluetooth. Support was greatly improved as well. When I'm saying Bluetooth, I mean through the Bluesy host stack. We added support for the ASHA profile, which is the audio streaming for hearing aids. So we support hearing aids using the ASHA profile. Auracast support was added. Auracast is the next generation audio broadcast profile that works on top of low energy audio. And yeah, we actually added support for it directly in PipeWire, so now you can configure your PipeWire server to be broadcasting to other devices, to other Auracast devices through Bluesy. Also, we added a new telephony API that allows making calls on the hands-free profile. So we previously had hands-free profile support mainly for headsets, to be able to work with headsets that have a speaker and a microphone. When you actually enable the microphone, it has to use the hands-free profile in Bluetooth Classic. But what we didn't have support for was support for pairing a mobile phone and being able to make a phone call over HFP. So in 1.4, we added a new API directly in PipeWire that allows sending those commands through the HFP protocol to the phone and make calls, answer calls, get the status of calls, and all of that. This was actually this has actually been deployed in a production device and has passed official qualifications tests by the Bluetooth SIG. Other things, the ALSA plugin now supports the DSD format, which is a strange, like different kind of format. It's still raw audio, but it is represented very differently. We added support for RISC-V CPU and assembler optimizations for RISC-V. We added support for UCM split PCMs. This is when you have a device that on the ALSA level, it is one device, but it has many channels, and a certain group of channels actually represent a different physical device. So what happens there is that in UCM, in the use case manager, in the ALSA API, you can describe that device as being, like, you can say this channel and this channel actually are this speaker, and that channel are that speaker, and you separate them. And what would happen previously is we would use the ALSA library to figure out those two and create different nodes that would use the ALSA lib API to talk to the device, but with the ALSA device actually being the same underneath. So it was a bit complex, and what we did was we added support natively in PipeWire. So we take the metadata from the UCM and we expose it to the session manager, and then the session manager creates appropriate loopback devices directly in PipeWire, and that is a more sane view of the whole graph. The Echo Cancel module was upgraded to support WebRTC 2. The RTP streams added support for the precision time protocol and using PTP clocks to synchronize with other devices. So this is very useful for AES-67 and those very precise and very low latency audio streaming protocols. And there was some significant improvement also in the GStreamer elements of PipeWire. So now you can use PipeWire from within GStreamer. So basically, you can create a GStreamer application that sends or receives data to or from PipeWire. And the elements in GStreamer behave more like what you would expect them to behave like. Previously, there were a lot of misconceptions. It was a bit buggy, and it didn't work very well. And now let's talk about session management changes. Last year, again, in June 2024, WirePlumber 0.4 was released. WirePlumber is the session manager of PipeWire. I think I said it in the beginning. It's the component. It goes together with PipeWire, but it is released independently. And it is the component that is responsible for assembling everything in the graph, creating the devices, managing the devices, creating all the links between the nodes. It is responsible for applying policies, access controls, and all of these things. Because if you leave PipeWire alone, it doesn't do anything. You have to somehow create those nodes and create all those links. So that's what WirePlumber is doing. So in 0.54 last year, we added support for the role-based linking policy, which is the policy where you have a different sync per use case, like a multimedia sync, a navigation sync, a speech sync. Basically, this is what we have in AGL. This was actually done for AGL last year. This is used mainly in automotive use cases and also mobile phone use cases. And with the refactored implementation, it can now blend with the standard desktop policy. So we can also use it on the desktop if we want to. We can configure it. Some users are happily doing that, and I'm very happy to know that it works finally, because, yeah, some people actually want to do that also on their desktops. And I gave a talk last year at the GStreamer conference where I described exactly how these new role-based linking policy works. If you want to watch it, there's a video on that link. And the slides are available on my talk on Sked. So you can download the slides if you want later and use the link. In September 2024, we released 0.5.6, which added a lot of improvements in the configuration files. We solved a long-standing problem where we had problem with the load order because we didn't really have dependencies between components that were being loaded, so they could be loaded in a different order than intended, and it was problematic. We also added support for running distinct, like multiple instances with distinct responsibilities. So now you can have, instead of having one WirePlumber daemon that takes care of everything, you can have 1, 2, 3, 4, 5 instances of WirePlumber, each one having a distinct responsibility on PipeWire. So applying a different, doing a separate thing. And it's possible to do that now. And from 0.5.7 to 0.5.10, 0.5.10 was released about a month ago. There was no significant feature, but there were several bug fixes and reliability improvements. There was the split PCM support that accompanies PipeWire 1.4, and we also now support node grouping behind the loopback, so you can take a group of, you can start some application or some applications with a certain parent process, and WirePlumber is able to understand that if these processes are running with that parent process as the original creator of those processes, then it has the ability to group them together and put them behind the loopback and isolate them from the rest of the graph so that they think they run in their own space. Next steps. So I think the most, the thing that is being more looked at right now is the video handling. PipeWire is doing great on the audio side. Audio works amazingly well. There's a lot of things going on there, but for video, it's not so great. We are still not enabling video convert by default, as I said earlier. We don't have video filters or a video linking policy, which is actually very, very important. So all these things we are looking at next. And also Bluetooth improvements. So we are looking at solidifying low-energy audio support and Auracast and make them really, really great. The telephony API that I mentioned earlier is actually now being integrated directly into Bluesy, so that it's more easy to test it. And also, we want to abstract the HFP protocol, which is the old way of doing phone calls, and the LE Audio Call Control Profile, or CCP, which is the new protocol that will replace HFP in the coming years. So we want to look into that. And more codecs are being added all the time. Like recently, we added support for a variant of LC3 that is used in some Apple devices specifically. And there are also some improvements for real-time scheduling. If you're running a kernel with preemptor-T and you want PipeWire to behave really, really real-time, there were some issues there. There are still some issues there, but we are looking into those. On the session manager side, one thing we want to look at is implement proper access controls. We currently don't really do proper access controls, and that's a problem. So PipeWire supports access controls. You can have different applications being very isolated from each other and not being able to reach all the devices or change things in other applications or other devices. And that's great, but we don't really enable it. We don't really use it. So we need support for that. We also need video linking policies or video policies in general, what to do when we have video nodes and we want to link them together. We are also looking at improving the Lua scripting based on feedback that we've received. WirePlumber is heavily based on Lua scripts to build the policy, but there are some issues there, and we're looking into those. And also, we're looking into moving things towards using Rust. Like PipeWire and WirePlumber are mainly written in C, but we would like to be using more Rust, and there's a new library in the works, the PipeWire native RS library, that attempts to build the entire PipeWire protocol and APIs in Rust from scratch. And the goal is to be able to write clients and also to be able to write PipeWire modules in Rust at some point. And we're also looking to bring Rust into WirePlumber and be able to do the same, like write modules or write some clients using the WirePlumber API, but in Rust. That was all. Thank you very much. I think I'm a bit over time. I'm not sure if there is time for questions. But if there is anything. Yes?
Did you maybe measure the latency when you are sharing between, let's say, two different OSs on the same SoC, in terms of, for example, video sharing and stuff like that? What is kind of the expected result?
So what is the expected latency if you're sharing between two different OSs, different operatings? Okay. That's not really something that PipeWire supports natively. If you want to cross the operating system, let's say, boundary, then you would have to use something else, like Virtio or, I don't know, some other technology. Because PipeWire is only within the same operating system.
OK, thank you very much.
Yes?
Yeah. Related performance questions. So if you have built up your graph, right? How do you normally measure, for example, the CPU time taken by a certain filter, but also context switching? The rate of context switching matters, especially as you make it more multi-threaded and multi-process. How do you evaluate that? What kind of tools do you have? And do you also think that you need to develop maybe something particular for PipeWire to do that kind of analysis?
Yeah. So there is a native PipeWire profiler tool that is able to get timings from when a node is, let's say, triggered to the time that it's finished. So we can collect for each node in each cycle of the graph, we can collect precise timing for each node, when it was triggered, when it actually started processing, and when it finished processing. And yeah, we have the tool, we have the data dump. What we don't have very good support for is visualizing that. We only have PipeWire top, and we have another HTML SVG generator that generates some graphs, but It's hard to see the data sometimes there, and you have to dive into the actual numbers to see what's happening. But PipeWire top already gives you good visibility at a higher level of which nodes are taking more time and things like that. And we've also done tests with perf. Perf works quite well for seeing the context switches on the server side and on different threads. So you can measure with perf how many context switches you have and how many instructions are executed per thread. And you can do some analysis with that. OK, I think I'm really over time now.